Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the problem sum of distances in a tree. Its index is 834 and it is the hard type problem, the LeetCode. Okay, so the one thing that is quite noticing over here, you can see that I have already added it to the list of the problems, like one of my favorite problems. So I would also recommend you guys to do that, because once you are revising some of the concepts like of dynamic programming and graph theory related type like depth first search and all that, then this is the one of the problem that you need to revise it. Okay, revise it like you are going to solve it again. Okay, and also you can see the number of likes over here is already a huge, because this problem is actually going to teach us something, how to optimize our code and how to think in the efficient way to compute the answers. Okay, I will tell all that concepts in this video. So the thing that you have to do is to hold some patience, and let's continue with the problem. There is an undirected connected tree, okay, with n nodes labeled from 0 to n minus 1, and since it is a tree, it has n minus 1 edges, and we have been given the integer n, the array of edges, where the edges of I is going to denote the two integers, where there is an edge between the node ai and the node bi in the tree. So basically we have been given the edges, n minus 1 edges in the form of a vector, and vector size will be 2, and the first, like, there is an edge between ai and bi, and we have to return an array of answer of length n, where answer of I is the sum of the distances between the ith node in the tree and all the other nodes. Okay, so finally what we have to return with respect to this problem, with respect to the given tree, is the vector, where the ith element of the answer will be the sum of the distances between the ith node in the tree with respect to the all the other nodes. Like in other words, you can also say that if we have to answer for the ith node, like answer of I, then answer of I will hold the value of what is the sum of the distances of all the nodes with respect to the current node. Okay, if you're not going to understand the statements, no need to worry about. I'm going to explain all those with the help of examples, and also I will provide the best visual explanation in the all possible ways. Okay, so let's head over to the constraints now, because this is going to help us. And how this is going to help us, let's analyze this term. N is like 3 into 10 raised to the power 4. Now you can see that we cannot have a O of n square type solution, because if you consider that, then like time limit is going to be like very much used, because the number of iterations will go around 10 raised to the power 9. You can see the, if you square this one, is it is like 9 into 10 raised to the power 8. So it is around 10 raised to the power 9, and this is not good. We are not going to follow that. So what we are going to do is we are going to have O of n time solution and O of n time, like O of n time and O of n space complexity type solution. Okay, I will discuss all those. Okay, so for now let's head over to the examples to analyze this problem, and then we will together build up the best solution for this problem. So let's move further. Okay, so suppose that this is the given tree. Okay, and we need to return the answer vector. Okay, and this answer vector is of size n, so that like we have to return for all the nodes. Okay, now suppose that for a certain case we have to return the answer of I, where what is the meaning of this answer of I? Let's first understand that. Suppose that this is the ith node, and we need to fill the answer of I. So what is the answer of I value? So answer of I value is the sum of the distances, or you can say sum of the distances of all the nodes with respect to this node, and that is with respect to the ith node. Okay, so if you consider the ith node as the root node, then you need to find out the distance of all these nodes with respect to this ith node, and in turn you can easily understand that some of the distances, like summation di of all the nodes with let's say summation dj, all the for all the nodes with respect to the ith node being considered as the root. So in other words, you can also understand this as the depth of each node with respect to the ith node. Okay, so what is the depth of ith node with respect to itself? It will be always 0, obviously. And the node B has the depth equal to 1. C also has a depth equal to 1. D also has a depth equal to 1. E also has a depth equal to 1. And so on. Okay, and you can see F, G, H, I, J, K, L, and M are all have the depth equal to 2. It mean, like for a particular node, if a depth is equal to D, it means that the distance of this current node with respect to the reference node, where the reference node is the current ith node, is the value D. And you need to sum up all these values. Okay, so what is the answer of I now? Answer of I, you can also understand this as summation depth depth of all the nodes. You can see depth of j, where j is going to vary from 0 to the n minus 1, and if all these are we are going to do with respect to the ith node being considered as the root. Now the thing is, like, you can easily find it out in O of n square time. How you are going to do that? Fix all the nodes one by one, where if let's say I'm going to fix answer of 0, if I'm going to fix it, I'm going to do a depth first search traversal or breadth first search traversal, and we are going to find out the depths of each node with respect to the current fixed root node, and it will take up O of n time for a particular node, and there are total n nodes, so it will take up O of n square time. But this is not we want. We want of O of n time solution. And how we are going to do that, how the all the things are going to be optimized, let's try to understand that. Okay, so let me just erase it first and then we will begin it. Okay, so yeah, here it is done. Okay, so now we need to find out the O of n time solution, right? So what we are going to do is, first of all, is like we need to find out we need to find out the answer of I for any ith node. Like you can choose any node. Okay, and if we have the answer, let's call it as X, then it is then it is obvious, or you can say it is for sure that we can find out the answers for all these nodes. And the extra thing that we need to know, like the prerequisite knowledge, or you can say prerequisite vector that we need to find out, is the subtree subtree of I for any ith node. Okay, so if we are able to have the value of subtree of I for all the ith nodes, and if we are if we are finding out the value of X for any ith node, then we can find out the values of all the places of this answer vector, like for all the nodes. Okay, with the help of this X value and with the help of this subtree of Y value. Okay, and how we are going to do that, let's try to understand that. Okay, one thing that I forgot to mention is that we are going to use the dynamic programming, and it is not like you are going to use a 2D vector or something like that. Okay, what we are going to use, we are going to pre-calculate the values of all these subtree of I, and with the help of this we are going to find out all the all the answer for answers for all the nodes. Okay, and this is going to be done only and only when if we have the if we are able to find out the value of X. Okay, so let's say that we need to have the value of X first, right? So let's say we have already calculated the value of X for this node, and let's call this as ith node. Okay, so X is already calculated. So let's calculate the value of X first to have a better understanding of this problem. As I've already said, for any ith node we need to know the depth. Okay, so the depth is 0 for this one, and this one first. So for depth equal to 1, there are exactly 4 nodes, and for depth equal to 2, I think there are exactly 9 nodes. That is 4, 2, 2, 2. What is that? Yes, I think. No. How many nodes are there? I'm confused. 4, 3, 7, and this one and this one, right? Then 7 plus 2 is 9, yeah. And for depth equal to, so there are 9 nodes and everyone is at a distance equal to 2. Okay, and for the rest of the nodes, all are at the depth equal to 3. So there are 4 nodes with depth equal to 3. I think the value is coming out to be 34. Yeah, 18 plus 16, yeah, 34. Okay, so we need to know the value of X, and we are going to use O of n time to calculate the value of X for any ith node. It doesn't matter, it's all up to you to choose any node. Okay, Now the thing is like how the answer is coming about. Okay, so you need to be like very much careful now, because I'm going to explain the very much important thing. Okay, suppose you are at a node V and you are going to the node U, and where V is the parent node and U is the child node. Okay, and the answer. Okay, now the thing is like ith node is this one. Okay, now the answer for the node V, we like is already known. Okay, because we are starting at the ith node, and the answer for the ith node is X, and we are then moving to the all the child nodes one by one. Like we are using the depth first search. Okay, so we are going to the one of the child nodes, then to the other of the child nodes, and so on. Okay, so if we are having the value of X for this parent node, and if we are moving to the child node, we can find out the answer for this node. Let's call it as y. We can find out the answer y with the help of this x and the subtree sum of like the subtree sum for all the nodes. Like mainly we are requiring the subtree of u. What is the number of nodes that are being included in subtree of u, where u is the child node of v? Okay, so let's try to understand that with the help of short example. Okay, so what we are going to do is we are at this node, ith node, and the answer for this is 34, and we are going to move to this node, right? Okay, so initially the base node or the root node is going to be taken as this one. Now the root node is being shifted to this one. Okay, so x, initially our answer is x, and the answer becomes y. So what is the difference in the answers that we are going to hold? This is going to be like very much important. Like if we move from the node V to the node U, how much our answer is going to differ? And we can easily calculate that. Okay, let's try to understand this thing. Initially our root node is this one, and the root node is going to move to this one. So whatever the node that is lying in the subtree of U, note that I'm also repeating it once again. Whatever the node that is lying in the subtree of U, all those depth will be decreasing by 1 if I will shift from node V to the node U. Okay, I think this is clear now. This statement is very much easy. If you take this as the root node, you can see the depth are 1, 2, 2 for like for all these three nodes. Okay, and if you take this as the root node for all the nodes that are lying in the subtree of this U, you can see that all the depths become like the current depth minus 1, like the 1 minus 1, that will become 0, and 2 minus 1 it will become 1, 2 minus 1 it will become 1. And in other words, you can also understand that if my answer is x, and if I'm moving to a child node u, my answer x is going to be decremented by the number of nodes that is lying in the subtree of u, right? Yes, it is correct. And how much more the answer is going to differ? What about the all the other nodes? Okay, and this is going to very much important. What about the all the other nodes? We have already accounted for all the nodes that are lying in the subtree of U. What about the all the other nodes? How we are going to find out the depth of all these ones? Not finding out the depth, we need to find out the difference of answers. Like we need to find out the value of y, and we have already known the value of x, and we need to know how much the answer is going to differ and what will be our final answer. Our main aim is to find out the answer for the current node, that is if you are moving from the parent node v to the child node u, and if my answer for the node v is x, we need to find an efficient way to move to find out the answer for the node u. Okay, now what I have done is like if I'm going from node v to the node u, you can see that my answer is initially was x at the node v, and if I will shift my root node to the node u, my answer will be decremented by number of nodes that are lying in the subtree of u. Okay, and u is the child node of the v. You can see that if I will take u as the reference node, all the nodes lying in the subtree of u has like their depth will be decremented by 1. So in other words, you can write down the answers as answer will be decremented by number of nodes lying in the subtree of u. But this is not sufficient. There is one more change that you need to do, and like answer will be incremented by, note that I am finding out the value of y, answer will be incremented by some other term also. Okay, and what is that other term? You can see that for all the nodes except the nodes lying in the subtree of U, like here it is 3, and the total number of nodes, I don't know how many are there. Let's say total number of nodes is T, and for all the nodes that is lying in the subtree of U, like there are total T minus SU number of nodes. You can see that if I will shift my root node from this one to this one, all the depths are going to be increased by 1 because one extra edge is going to be encountered over here. You can see that this is the extra edge, and the thing is you need to increment down the count of those nodes. It is actually this one, T minus SU, where T is the total number of nodes. Note that I'm repeating it once again. T is the total number of nodes, SU is the number of nodes lying in the subtree of U. Okay, so why is the current answer? So overall, what we are going to do is, like, first of all, we are going to find out the value of x, where x is the answer of y for any ith node in O of n time, either using depth first search traversal or breadth first search traversal. Again, what we are going to do is we are going to move, like, again use a depth first search traversal, and from going from current node V to the node U, if we have the value of x, like at the node V, which is our answer, and if we try to move to the child node, any child node, then our answer for the child node will be answer for the parent node, which is x minus number of nodes lying in the sub number of nodes lying in the subtree of the child node, plus number of, like, the total number of remaining nodes, T minus number of nodes lying in the child nodes. And the reason is, as I've already said, if you shift your root node to the child node, from the parent node to the child node, all the nodes lying in the subtree will have their depth decremented by 1. In other words, you can decrement your answer by the number of nodes lying in the subtree of the child node. And what about the remaining number of nodes? The remaining number of nodes will be, like, their depth will be incremented by 1. So in other words, you need to increment your answer by the count of that nodes. So this will be your answer. Okay. So let's move on to the coding part, where I will explain all these things in a bit detail also, and we will analyze the code. So let's move further. Okay, so let me just show my submission. Okay, so time complexity will be O of n, space complexity will be O of n. This is what we want. So what I've done is, like, initialize the answer will be everything will 0, and subtree size will be initially initialized with 1, the current node, and there will be adjacency list representing the graph. So first I've iterated in the edges and push back the elements in the adjacency list, and first I will find out the, like, we need to find out the value of x, where x is the, like, answer for the any ith node. I have taken the node as 0. You can take any node, it doesn't matter. And I have done the DFS traversal, and along which I am going to fill up the subtree values also, where the subtree of I is going to denote the number of nodes lying in the current subtree, including the ith node. That's why we initialize the subtree with 1 also. Now note this DFS function. Okay, so note that current is like, this is the DFS function returning some integer. Okay, and this current is going to store the answer for the current, like, for the current node. Okay, like, what is the answer for the current node? Where the answer for the current node is, you can see that it will be the answer for all those child nodes plus the subtree of U, value of these subtrees. Okay, and you can easily understand with this one is, let me take another page and explain. Like, in this function, what we have done is we have already finding out the subtree values, okay, for the current node. And if we try to find out the answers for this node, let's say, and the answers for this node will be, what are the answers for all these nodes plus the subtree values of all these ones. Okay, you can see that if we find out the depth of these ones, with respect to this node being taken as root, you can see that depth of this one is 1, 1, 1, and it is 0. So if we try to find out the this node, like, answer for this V, it will be like, what are the nodes, what are the answers for all the nodes that are the child nodes of these ones. You can see answer for this one is 0, answer for this one is 0, answer for this one is 0, so it will be like 0 plus, and you can see that when I will take this node as the root node, reference node, and we need to find out the answer of v. The distance that is extra, the extra distance that is being added is all these edges you can see, and this is actually the sub. You can see this is actually what we need to increment the subtree values of all these ones. So we will be adding this one. You can see that answer plus equal to subtree of u, because whatever the nodes that are lying in these subtrees, we need to increment with that also. Okay, so if you're not getting it right now, let me take another big example which will make it clear for you. Okay, suppose we are adding for this one. Okay, and for like we need to know the answer of v for this node. Okay, if I need to explain for the answer of v, we need to know the answers for all these child nodes, right? Let's say answer for all these child nodes, let's say sigma answer of u, where u is the child node for all for the node v, and there is one more extra term that we need to add. And what is that extra term? For all the nodes that are lying in this, like for all these nodes, let me just color in the red. You can see that for all these nodes there is an extra edge that is being added. That is what I'm going to explain over here. Okay, you can see this extra edge has been added, this extra edge has been added. So in other words, our answer will be incremented by summation subtree of u, where u is the child node of the node v. So this will be our answer for the current state. That's what I'm going to do. If u is not equal to parent, current plus equal to answer for all those child nodes, and we need to increment our answer to the subtree values also. And this is what we are going to do: subtree of v plus equal to subtree of u. And we are also incrementing the current size of the subtree for the node v. Okay, so the main function, the main thing that is going to do over is that this DFS function. Okay, you can see that I've named these two functions as same because it doesn't matter. The parameters are going to be different, prototypes are different. So answer for V is the now. Note that I passed the root answer, like the current answer for this node 0, and initialize answer with always with this one answer of V with now. And when I'm moving to the parent, the thing that is going to differ is my answer will differ by now, that is the current answer minus subtree of u, that is whatever the nodes that are lying in the current child node u, answer will be decremented by that value, and whatever the rest of the nodes are subtree of u, sorry, subtree of 0 will be the total number of nodes minus subtree of u. Okay, will be the remaining nodes. Every node will be like answer for these one will be incremented by 1. So my current answer will be changed by this amount. Okay, and I'm passing this to the DFS function so that for the next call, my answer will be initialized with this value. Okay, and if all these goes well, I'm finally going to return the answer, which is the answer for the required problem. So if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and if you have any doubts, do comment it, and also join our Telegram channel for the discussion group. And thank you for watching this video.